I'm going to go ahead and show you today how to go about composite figures, specifically how to find their areas. First, just realize that a composite figure is composed of two or more basic shapes, two or more basic figures. That's why they're called composite figures. For example, on this first one, we have what looks like a triangle and what looks like a rectangle of some kind. And so eventually, the two shapes that make it are again a triangle and a rectangle. And you'll see that that is basically what we're going to be doing when we're looking for the areas. Break it up into smaller shapes. Let's go ahead and look at the next one. So on the next one, we can easily identify this as a half circle. And then from here you have options. You could go ahead and break this up into triangles if you want, but this on its own is a trapezoid. So it pays off to know your shapes. That way you don't do extra work. Let's look at this next one. And on this next one, we have two different half circles. And again, you could break this shape up into triangles and rectangle, but it pays off to know your shapes. This is just a parallelogram. You know your shapes, you break them up, you eventually need to know the main properties of each one. Keep in mind that if you're looking for the semicircles, to find the areas, you need radius. To find this one, you need your base and height, right? So again, make sure you know how to find the individual areas. If not, go and look at that specific video. I'm just going to go ahead and do two examples here. So this first one, it's a very common example, very common problem. And so the two shapes that we see are this triangle right here and this rectangle slash square right underneath. So I'm going to go ahead and find the area of both of these shapes. I'm going to start off with this triangle one. And at the moment, I know that this is 20 and the actual height of this triangle is 12. But I don't know the base. Well, here's the thing. Well, because I have an actual square in the bottom, it turns out that this is a very nice isosceles triangle. And since this line cut it right down the middle, we could just say that we're going to call this x for now. Okay, so you don't even need to know that part. But notice how we create a right triangle of some kind, and all we're going to do is we're going to do Pythagorean theorem. So I do Pythagorean theorem, I'm going to do 20 squared minus 12 squared. (20 squared minus 12 squared). And I get 16. So I know that this is 16. So this is 16, and obviously this is also 16, which makes a whole side of the green figure to 32s. 16. To find the area of the triangle, base times height divided by 2, because it's a triangle. So it's going to be 32 times 12 over 2. So the area of the triangle, 32 times 12 divided by 2, is 192. To find the area of the green figure, well, I now know that every single side is 32. This is just a square, so it's just going to be 32 times 32. So 32 times 32, which is 1024. So the area here is 1024, the area here is 192. If I want to find the total area of the composite, I actually just add them up and that's it. So the total area is 1216 because we added these two together. An area of composite, break it up into different shapes, and then just add them. This was a simple problem. Obviously, there will be more difficult ones where you might have to do more Pythagorean theorem or SOHCAHTOA or law of sines to find unknowns. But in general, that's how they're worked out. Break them up, find the area of each one, and then add them. That's why it's important to know how to find the area of basic shapes. Let's look at this next one. This next one, it's not necessarily a composite figure, but you can pretty much treat it the same. So on this one, they're asking for you to find the area of the shaded region. You could think of it as we have a big shape here, it's a hexagon. Where each side is currently 7. And we also have a rectangle, the rectangle here, where you know that this is 7 and this is 14. So to find the area of the rectangle, that's actually pretty simple. It's just going to be 14 times 7. So the area here is going to be 98. Now, since they only want the shaded region, if you think about this popping out and you had to paint it or color it or something, obviously you don't color in the square. So we're going to have to find this area here and then just subtract 98 from it. Now, in order to find the area of a regular polygon, this is a hexagon. Remember, there's a formula that's out there, and it's just area is your apothem times perimeter divided by 2. Since it's a regular polygon, and I should have indicated with tick marks here, all sides are 7, there's 6 of them, so 6 times 7. I know that my perimeter at the moment is 42, but I don't know my apothem. So again, this is one of those problems where you just have to do some little extra steps, go back and look at those videos if you need more examples. But basically, I'm going to draw my apothem, and I'm going to create a right triangle. I'm going to find this angle by doing 360 divided by 6 because there's 6 sides, and then I'm going to divide that by 2 again. So this angle right here is 30 degrees. I'm looking for the apothem. This is obviously only half, so this is 3.5. And so all I'm going to do is I'm going to do a quick law of sines again. So this apothem that I'm looking for is across the 60 degrees. And the one that I know, the 3.5, is across the 30 degrees. So quick cross multiplication, 3.5 times the sine of 60 divided by the sine of 30. And so I find out that my apothem is pretty much 6. So now I just plug it in, and 6 times 42 divided by 2 is 126. And again, we're at that last part where they only want the shaded region, so I'm just going to subtract them. Minus 98. And so the area of only that shaded region, only the green section, is actually just 28. That's it. A little more complicated problem just because we had to find the area of the hexagon, but with practice you guys will be able to do those really fast.